Hi everybody, and welcome to lecture 9. And today we're going to talk about categorical variables. So let's dig into it. Okay, so still we are trying to model or to build a model to forecast outcomes from data we have. And of course, I like to use the word predict because we're not dealing with time series models yet, and that will be next lecture. And what we are doing now is kind of to predict an outcome given some data we have and a model. And we are making kind of prediction interval and point predictions. So I like to think of forecast as something you try to predict into the future. Okay, so we're going to look into that in lecture 10. Okay, so still we are trying to make the best model we can build. And what's new in this lecture is that we are making comparisons across different categories. Okay, so if you think of categories as categorizing stuff, then you're correct, because kind of you just put different like data items, well, you can say different companies. Maybe you have tech companies in this first box, and you have industrial companies in this second box, or it can be two different companies, or it can be whether or not the subject you're working with differs in two different ways, or in three different ways. So it can be seasonal data you're dealing with, and you're trying to look at differences across seasons. Okay, or taking account of seasons. Okay, so this is kind of what we're dealing with now, and these categories they can be numerical, but often they are just categories, like names or tags. So the agenda for today is that we are building a regression model, which is, well, a regression model is our tool, our main tool in this course. And we are building a regression model for two or more groups, and we are interpreting these models with categorical variables and interactions. Okay, and categorical variables is like 0 and 1, and interactions could be if you have x1 plus let's see if you have your regression model, for example, y equals, or y hat equals b naught. Let's see. I have to. Okay, I think this is better. If you have like your explanatory variable, and you have another explanatory variable, that should be 2, right? We do like this. So this is 2. And then you can have like an interaction between these two variables, and estimate this interaction. Okay, so for example, if x1 can take on the values 0 or 1, and x2 variable is numerical, then this interaction term is either 0 times the numerical variable, or it's 1 times the numerical variable. Okay, but we're going into that later. So today we're covering chapter 25, and we have to define the categorical variable, and it's just a variable that can take on a fixed number of values, and these values might be numerical, or they can be like tags or strings. Okay, and this value, it assigns all observations to a certain group. Okay, a category. And examples can be whether a person has a car, yes or no. For example, if the person has a car, you can assign the value 1, and if the person does not have a car, you can assign the value 0. And if the variable, the categorical variable, has this either 0 value or the 1 value, then it's a dummy variable. And later we're going to talk more about dummy variables, and but for now, examples of categorical variables could also be the county where a person lives, and there are more than 2 counties, right? So this categorical variable might look like this. So you have a person or a name, you can say, and you have a county name, and you have county number. Okay, so for example, Jane lives in the first county. Okay, let's call it New York, and Pablo, he lives in the second county. Let's call it Madrid, and that's the second county. And Fang lives in Shanghai. That's the third county. And these numbers, they are just arbitrary. Okay, so you could call Madrid the first county or whatever, but these are just to identify the county in the data set. Okay, so what we why we care about these categorical variables, they allow us to compare groups while controlling for confounding variables. Okay, remember these lurking variables, because, for example, if you're interested in whether students who have an iPad have higher grades than those who not, then you might find a difference, positive or negative, but is that difference in grades due to actually owning the iPad, or is it something else? Okay, because you have like if the grades that's your y variable, and x variables are here, so that would be iPad. Let's say iPad. Okay. And what kind of other variables might affect the grades? So maybe you have hours of study, and maybe you have GPA, grade point average from high school. Okay, my writing is really off today. Okay, so if you only include, or if you only look at the difference in the means between two groups, then you're not accounting for or controlling for the omitted variables, the confounding variables. Okay, so that's why it's really practical to include categorical variables in your regression, because in your regression you can control for all these other variables. So that's so the point here is that the confounding variable, no, the categorical variable allow us to test our hypothesis while controlling for all these omitted variables. So for example, you want to know the effect of providing extra vacation days on the performance of your employees. And the question is, does the effect differ depending on whether the employee has kids? Okay, whether or not the employee has kids and how many kids. Okay, so for example, the extra vacation days might be a binary variable, a dummy variable, like 0 if the person did not get vacation days, and 1 if it did get vacation days. And actually, whether or not the employee has kids might also be a dummy variable, 0 if the person does not have kids, and 1 if the person does have kids. So or you can control for the number of kids as well. Okay, so of course we have a case study, and today it's Airbnb. And Airbnb, for those who do not know Airbnb, probably most of you do know Airbnb and probably have used them at one time or another. It's an online marketplace for sharing homes and experiences. Well, basically, it's a marketplace for getting a place to sleep. Okay, and it's like booking a hotel, right? And Airbnb connects hosts with spare rooms, right? And travelers, they can just go online and look for a place to stay in the app. Okay, and you can of course set, if you're going to rent out your bed or a couch or a room, you have to set a price. Okay, and what you're interested in is to set the maximum price, which still enables you to actually get a customer. Okay, so they provide you with a price tip, and the question is how is this price tip how is this price tip actually generated? Okay, because you see that according to the price tip, it's here, right? But you've set a price of 199 euros, which is here, and it's in the red, so probably you will not get many customers, even with this high price. So how do Airbnb actually create this price tip? It's by regression model, just what you're learning in this class, and this is actually a very short paper, and it's found on the Google Scholar. So if you go to Google Scholar, then you can download this paper and have a look. And they developed regression models to generate price recommendations for you as a host. Okay, so what we want to do is something else than Airbnb does, but we would like to develop a regression model to describe the listing prices, and we'll just assume that all the multiple regression model conditions hold. We're not spending time on that. If you wonder what the multiple regression model conditions are, then you just watch some of the earlier videos. But you always check the multiple regression model conditions first, and then you can do inference. Okay, so what we are supposing is that the marketing department at Airbnb has asked you to analyze the following questions. Okay, do superhosts charge lower prices? And well, superhosts, they okay, I think they have high ratings and low cancellation rate. Maybe a couple of more dimensions here, but they are kind of like a special category within the Airbnb hosts. Okay, so do these superhosts charge lower prices? Okay, that's one research question. And the second research question is the effect of an additional bedroom on listing prices different between superhosts and non-superhosts? Okay, so what we already know is that we need data for two different groups, and we need the prices for these different groups, and we need the bedroom, the number of bedrooms. Okay, so we have, of course, data on Airbnb listings, and at this site you can go to this site, and you can find a lot of data from Airbnb, and for different cities and different kinds of data. So you have a lot of data available freely. Okay, this is free data. So you have the listing ID. This is kind of the room or the apartment, and you have a host ID, because one host might have several apartments, and whether or not the host is a superhost, and here f equals false and t equals true. So if the host is indeed a superhost, then you have a t for true in this column, and you have the property type, and that would also include house and other, maybe just like a room. Okay, and here you have the number of bedrooms, and you have the price per night. Okay, okay, so now you have some data to work with, and immediately you see that the superhost here actually offers a lower price than the non-superhosts. But we have to look into all the superhosts and all the non-superhosts to actually find the bigger picture. Okay. So, for example, here, do superhosts charge lower prices? We're going to use a simple t-test, and that would be in the next video.